In today's lesson, I'm going to do a few questions on radical functions, finding domain and range, and radical plus reciprocal function, how to find the domain and range of that, and then reciprocal function with the non-linear as a denominator. So I'm going to do a couple of examples on that. So first example is determine the domain and range of the radical function y is equal to 2 minus a square root of 2x plus 3. So we are going to do algebraically, and then we'll confirm the result and then confirm graphically. So now how to find, and whenever we are finding domain and range, we are talking about real numbers. So we are going to find first the domain and range. First thing is that whenever you have a square root function, for example here 2x plus 3, so this function consists of a square root or a radical function. So then we know that this whatever is inside the radical has to be greater than equal to 0, because we are talking about real numbers here. So this has to be greater than equal to 0, which means 2x is greater than equal to negative 3 and x is greater than equal to negative 3 over 2. So the domain of the function here in this case is x belongs to R, x not belong to R. So the domain is x has to be greater than equal to negative 3 over 2. So you can write like this, or you can say x such that x is greater than equal to negative 3 over 2. But this x is R. So we are talking about real numbers here. Now for range, to find the range, now this one, if let's say that this factor is equal to 0, then the y can take the value which is equal to 2. So that is the largest value y can take, because if this is equal to 0, then y will be equal to 2. So the largest value y can take is 2, which means the range is y such that y is less than equal to 2. So that is the range of this function. Now we are going to confirm this graphically. So we are going to graph this function here. Okay, so I'm going to graph this here. So when you have this, let's input the function 2 minus square root of x plus 3. Sorry, that's not the function. Delete. So we have 2x plus 3. And if I graph it, so you can see from the graph here, the maximum value of y can be equal to 2. So the range is less than equal to 2. And then again from the x value, you can see that it starts from negative 3 by 2, which is negative 1.5. So it's very clear from the graph as well. So graphical is the another way you can confirm the domain and range. But you need to know both ways, algebraically as well as graphically. Okay, the next question is domain and range of a function which is a reciprocal as well as a radical. So if you look at this consists of reciprocal, which is 1 over something, and then in that denominator you have a radical function. So we know that for radical function, if we have x plus 1, this has to be greater than equal to 0, which means x has to be greater than equal to negative 1. But here, since this factor is in the denominator, and for reciprocal function, if I have 1 over x, you know that x cannot be equal to 0, which means in this case, for this function, to find the domain of this function, x plus 1 has to be greater than 0 only. Okay, so it cannot be greater than equal to 0, which means x is greater than negative 1. So that is the domain of this function. So domain in this case is going to be x. Again, we are talking about real numbers here. So x, and then x is greater than negative 1. So that is the domain. Now after that, we need to find the range. Now range of this function is, since the numerator of the function is non-zero, which means y can never take the value equal to 0, which means y has to be greater than 0. Now, whatever is your domain, the restriction on the domain help you to find the asymptote. So in asymptote in this case, the vertical asymptote in this case is going to be x is equal to -1. And from here, you will get your horizontal asymptote, which is equal to y is equal to 0. So first thing, whenever you have to find the asymptote, first step you should do is find the domain and range. So whatever is the domain and the range, or whatever is the restriction on domain and range, will be your vertical and horizontal asymptotes. Okay. The next question is finding the domain, and then you have to state the equation of the asymptote or asymptotes. So let's see here. So the difference here is that we have a constant function in the numerator and we have a non-linear quadratic function in the denominator. So whenever you have this thing, first thing you need to do is see if you can factorize the denominator here. So I'm going to rewrite this as -2. Now I need to see 2x squared minus 3x minus 9. If I can factorize it, so 2x, and then let's try with 3 and 3. So this gives me 6x and 3x, and I need minus 3x, which means I have to put negative here. So 3 multiplied by 3 gives me -9, and when I multiply this gives me minus 6x plus 3x, which is minus 3x. So the factors of this is 2x plus 3 and x minus 3. So we got this 2x plus 3, and then we have x minus 3. So the domain of this function is, they only ask the domain of this function. Domain of the function in this case will become x, and x is your real, such that x is not equal to -3/2 and x is not equal to 3. So because this is in the denominator, if you will have x is equal to -3/2, the function is not going to be defined. And if you have x is equal to 3, again the function won't be defined. That's why you have here domain is x belongs to R, and x is not equal to -3/2 and x is not equal to 3. So this also gives you vertical asymptotes. So vertical asymptote in this case is going to be x is equal to -3/2 and x is equal to 3. If they will ask you to find the range in this case is again going to be y, such that y is not equal to 0. It has to be y equal to 0 is not possible here. So which means the horizontal asymptote in this case is y is equal to 0. Again, the numerator is a non-zero number. That's why you cannot have y is equal to 0. So no x value will give you y is equal to 0. So your horizontal asymptote in this case is going to be y is equal to 0. Okay, that's it for this lesson.